On this episode of the Center Shots column on BOWHUNTINGmag.com, it would be a complement to the June issue. So if you go back and look at that, I was talking about how to select a compound bow. There's a number of criteria that you look at when you're selecting a bow, and one of the ones that I think is probably a little bit misunderstood is the brace height. And I look at brace height, axle to axle length, I look at the IBO speed of the bow, and a few other criteria when I'm looking at hard numbers. The rest of it all has to do with how the bow feels when you shoot it and how much noise it makes. So really, let's look at the aspects of the shot that have to do with the numbers. Brace height is the measurement from the back of the grip to the string. So that's a distance typically, I would say, on a mid-performance, medium forgiving bow is somewhere around 7 inches. That's kind of like middle of the road. Anything down in that 6-inch range is a fairly aggressive brace height. Anything over 8 inches, I'd say, is a highly forgiving brace height. And it's a little bit of splitting hairs on brace height, but there is some physics behind it. Basically, what it means is when the bow has a low brace height, you're pulling the string back under force further. So I mean, for your given draw length, if you're a 29-inch draw and you've got a 6-inch brace height, you're basically pulling it back, let's say, for the sake of argument, 23 inches. You're putting force on the string for 23 inches. Now if it's got a 8-inch brace height, you're putting force on the string for 21 inches. You're not loading as much energy into the bow. And that's why dropping the brace height on the bow potentially allows you to store more energy in the bow, which then also makes the bow faster. The downside to brace height is, as the string is going forward, the arrow is attached to the string longer. So as it's sort of like, go back to the muzzleloader days when everybody was shooting the old flintlocks. There was a certain lock time. Pull the trigger and then poof, and then the shot went off. And you had to hold your follow through real steady for a lot longer, when it took longer between the time when you triggered the shot and the time when the ball left the barrel. So it's the same thing with brace height. The longer the arrow is attached to the string, the more time you have if you have a flinch in your form, or if you're snapping your bow hand closed during the shot, or maybe dropping your bow. The arrow is just attached to the bow longer, so that gives you more time to influence the flight of the arrow. So getting the arrow off the bow quicker, in theory, with a higher brace height, makes the bow a little bit more forgiving. A little bit slower, all things equal, but a little bit more forgiving. So anyway, that's the trade-off with brace height. I've got a couple other bows here. I'm going to pull up a few as we go here. Now let's talk about axle to axle length. This is another thing that really has come on as a trend, let's say, in modern bow design. People like short bows, and there's really no physical argument for it. Are we so weak now that we can't carry an extra ½ pound to the tree stand? Where we walking like 50 miles to our stands now? I'm a little bit sarcastic about the weight and the shortness of bows, but at the same time, I know people like portable bows, so I'm not going to argue. But purely from the physics standpoint, the longer the bow is and the more it weighs, the more stable it is. You can't move it as quickly. It's the inertia. A heavy bow, you can't just jerk it around, and you can't twist it real fast. A longer bow, it's like taking, which is easier to move quickly. A short rolling pin, let's say, that weighs 4 pounds, or a long fence post that's 6 or 7 feet long that weighs 4 pounds. They weigh the same, but the longer object is a lot harder to move quickly because of the rotational inertia, or the inertia of the body. Same thing with a bow. For any given weight of a bow, the longer it is, the more stable it's going to be. And the more it weighs, the harder it is to accelerate it by moving it quickly. So, you take it as far as you want to. For me, I'm a realist, I guess. I know that people aren't going to want to shoot longer bows and heavier bows anymore. But, from a purely a physics standpoint, a longer bow is going to be a more stable bow. So, where do you draw the line? I don't know. There are 28-inch bows on the market, and there are probably 37 or 38-inch bows on the market. There's not much longer than that, and there's not anything yet, to speak of shorter than that. So, it's from a hunting bow standpoint, you're not going to give up a whole lot of accuracy when you drop from, say, a 35-inch bow to a 28-inch bow. You're going to give up a little bit. There's no question about it. If you're taking only 30-yard shots and closer, you'll never notice the difference. If you're one of those guys that competes in 3D tournaments or takes longer shots while he's hunting, I think a little bit longer bow with a little bit more mass weight is going to be more stable for you and make you a little bit more accurate on these longer, more demanding shots. So those are the two criteria that I'm going to talk about from a number standpoint in this episode. The final one is just when you shoot the bow, it's all going to boil down to what it sounds like and what it feels like in your hand when you shoot it. I like a bow that my hand goes into real comfortably, where the grip is real comfortable on the bow. That way I know I can relax my hand during the shot. Today's bows, and this Matthews is a classic example of how parallel and beyond parallel the limbs have gotten. When we draw this bow, you can see the limb is already slightly beyond parallel, with the top limb to bottom limb. It's going to go even further. So when you fire it, the limbs recoil straight up and straight down. So they cancel each other out, and you don't get any forward lurch of the bow during the shot. So that's stuff that you'll notice when you shoot the bow. Also how quiet the bow is, how it feels in your hand. It should jump just a little bit straight forward for you, or not at all. You don't want the bow to spin in your hand when you shoot. So anyway, those are the kinds of things you should be looking at. I know I didn't get into all the subjects that I talked about in the article, but there just isn't time in these videos. Hopefully, though, those are two of the issues that are maybe a little bit more controversial, maybe a little bit less understood from the standpoint of bow selection. So come back and join me again next month for the July issue of Center Shots column on BOWHUNTINGMag.com.